Trump announces his choice for the new NASA administrator. We've got a new date for Artemis III. Venus might never have had liquid oceans, and finding habitable planets around white dwarf stars. All this and more in this week's Space Bites. Since his re-election, Donald Trump has been announcing all of his proposed candidates for various key positions in the US government. And this week, we learned his choice for the new NASA administrator. It was kind of surprising. Trump chose Jared Isaacman as the new NASA administrator. If that name sounds familiar, Isaacman is a billionaire, so I guess another billionaire joining the US government. He is an experienced jet pilot, and he was the brains and the funding behind two private space missions. Inspiration 4, which flew 4 private astronauts around the Earth on a Crew Dragon capsule, and then Polaris Dawn, which also flew 4 private astronauts around the Earth, but also had the first private spacewalk. And Isaacman was one of the people that did the private spacewalk. He's a giant space nerd and has been behind a proposal to try to reboost the Hubble Space Telescope and other various spaceflight projects. So what does this mean for NASA? We have no idea. Now, on the plus side, he's a giant space nerd and clearly has spent millions of his own money flying to space, taking other people to space, performing a bunch of science experiments while in space. He loves space and wants humanity to become a true space-faring civilization. But he has no experience in government, in running NASA programs, in being a scientist. So we really don't know what it's going to be like for him to oversee all of NASA. He's mentioned how concerned he is about climate change in the past, so he definitely is looking at that from a scientific perspective. So right now, it is just completely unknown how this is going to work out, whether he'll get confirmed by the Senate. I will update you when we learn more. Artemis III won't fly until 2027. When I'm filming this, we had a big press conference from NASA giving us an update on the Artemis program. And learning that the press conference was going to be happening, what it was going to be about, we all predicted the same thing. And you're going to be shocked to hear that what we predicted was what they announced. And that is that NASA is pushing back both Artemis II and Artemis III several months. So originally, Artemis II was supposed to launch late 2025. They announced that Artemis II is now getting pushed back to April 2026. Artemis III was supposed to launch in 2026, and they announced that they're launching in late 2027. So why are we seeing the delay? Now, there's probably a whole bunch of reasons why they decided it would be good to push the launch of both missions back, but they focused this entire press conference on the heat shield. Now, when the Orion crew capsule came back from Artemis I, it passed through the Earth's atmosphere and it wore down its heat shield, and not in the way that NASA was expecting. Normally, when you have this kind of ablative material on your heat shield, you're expecting to see this material wear away while protecting the crew in the capsule itself. But what they found was that the material had ablated, but also had peeled off in little bits and pieces in a way that was not expected. And so this was a tremendous concern. NASA engineers spent a lot of time replicating the conditions of the return and tried to figure out exactly why this was happening. They learned that as the Orion capsule was entering the atmosphere, hot gases were building up underneath the top layer and then was popping out, cracking open this top layer of the heat shield. And that's not supposed to happen. Normally, any gases that build up should be able to escape through a permeable outer layer of the heat shield. To solve this problem, they're going to re-enter the atmosphere at a slightly different angle in a way that distributes the buildup of the heat over a longer period of time, prevents this buildup of the gases and then having it crack open. But the ramifications are that we're going to see Artemis II fly in 2026 and Artemis III fly in 2027. And NASA Administrator Bill Nelson was very clear to say that the Chinese are planning to land humans on the moon by 2030. So they still have time to beat the Chinese back to the moon. Like, we all have a lot of questions here, right? Which is that we don't know what's going to happen as soon as the Trump leadership takes over. What are the implications on NASA? Are they going to be switching away from the Space Launch System to some other vehicle? Will we see things fly on a Falcon Heavy with a different upper stage? Will we see things fly with Starship. Everything is completely in flux. Right now we have no answers, and so we're just going to have to wait for events to unfold, and then we will report on them. But I am as much in the dark as you are. Meerkat confirms the gravitational wave background of the universe. So thanks to LIGO, we have the direct observation of gravitational waves emitted by colliding black holes. But LIGO and Virgo and Kagra and the other gravitational wave observatories are limited by the maximum mass of the black holes that they can detect merging. They can detect the stellar mass black holes, but they can't detect the supermassive black holes, the kinds of things that are found at the heart of the Milky Way. Just last year, the nanograv experiment, based on 15 years of pulsar observations, announced the gravitational wave background radiation of the universe. These are the gravitational waves produced by merging supermassive black holes. Now, not any specific merger events, but just the general background. These things are happening everywhere across the universe. This week, astronomers used the Meerkat Observatory to confirm the existence of this gravitational wave background. As with nanograv, they observed millisecond pulsars. These are pulsars that are spinning hundreds of times a second. The radiation pulses are so regular that they can detect any slight changes in the movement of the pulsar and use that to calculate that these gravitational waves are flowing past. Meerkat observed more pulsars and was able to get a measurement of this effect in just 4.5 years, which is just a third of the time that it took the nanograv experiment. Now we've got a confirmation that this gravitational wave background is there, and it gives you a real hint at the power of the Meerkat Observatory, which is a prototype for the upcoming Square Kilometre Array telescope, which is being built in both South Africa and Australia and should come online in the early 2030s. And so these kinds of observations will become faster, become easier, and we should have a much better understanding of this gravitational wave background of the universe. And it's important to be clear that we're not talking about the primordial gravitational waves. Those are the ones that would have come from the Big Bang itself. These are the ones that come from the merging supermassive black holes that are happening across the universe at various points in time. It'll take future, even more powerful gravitational wave observatories or pulsar timing arrays to tease out that primordial gravitational wave background. Venus might have never had liquid oceans. Venus is terrible, right? It has this incredibly high temperature, this incredibly high pressure. It is inhospitable. If you tried to land on the surface of Venus, you would be crushed and boiled, and it would be a terrible experience. But planetary scientists think that maybe Venus was habitable in the past, maybe billions of years ago, but possibly even just a few 100 million years ago. And then something happened on Venus that kicked it into this runaway greenhouse effect where carbon dioxide was trapped in its atmosphere, the temperatures rose, and eventually it just became this unhospitable hellscape that we see today. But the expectation is that there were oceans in the past. It's very similar to Earth. Earth has oceans, maybe Venus had oceans. But a new paper has come out that says actually maybe Venus has never had oceans, that it's just always been too dry to support water on its surface. This prediction comes from examining the atmosphere of Venus and calculating how radiation from the sun breaks apart various chemicals in the atmosphere of Venus. The ultraviolet radiation breaks up water vapor in the atmosphere of Venus, breaks up carbon dioxide and other molecules. And then the solar wind can blow away some of the lighter molecules and the hydrogen off into space. So Venus needed a way to replenish those molecules in its atmosphere. On Earth, when we have volcanic eruptions, which replenish a lot of the gases that we have in our atmosphere, volcanic eruptions are almost entirely water vapor. They're steam. But on Venus, volcanoes contain only about 6% water vapor, with the rest being carbon dioxide and various sulfur compounds. And so that's an indication of how much water there is trapped in the crust of the planet. Earth has a lot of water trapped in its crust. Venus is clearly very dry in the crust, can't replenish its water, and so this is why it might never have had oceans on its surface. Could white dwarf planets be habitable? We're in the age of exoplanets, where new telescopes, new techniques are finding more and more planets orbiting around various stars in the universe. Now, To actually examine the atmosphere of a planet, you need to be able to distinguish the planet from the star that it orbits. James Webb has been able to do this a few times, but it takes very special circumstances, largely coming from the difference in brightness between a red dwarf star, which is not very bright, and then a planet that is orbiting around the star. As the planet passes in front of the star, Webb can detect the presence of various chemicals in the atmosphere of that planet. Now, we still don't know if red dwarf planets can have atmospheres. This is still an unsolved question. Hopefully we'll find out soon enough. But if it turns out no, then we're going to need to look at more massive stars more like the sun. But that means that you have to be able to block that light from the star. That's really complicated, requires new observatories like the Habitable Worlds Observatory, the extremely large telescope on Earth, and maybe the large interferometer for exoplanets. But there's another class of planets that aren't very bright and are known to have planets, and those are white dwarfs. White dwarfs are dead stars like our sun that used up all the fuel in their core, puffed out their outer layers, and then shrunk down to this hot core. When you see a white dwarf star, you are seeing the core of the star that is no longer doing fusion and now just cooling down, eventually to become the background temperature of the universe. And yet, there has been evidence of planets orbiting around these white dwarf stars. So could a planet around a white dwarf star be habitable? If the star was like our sun and it had planets in the habitable zone around it, when the star dies, you're not going to get those planets migrating down to be in the habitable zone of the white dwarf. But you could have debris collect together and become a planet that is in the habitable zone. And in a new paper, astronomers calculated that you're going to get this habitable zone around a white dwarf for about 7 billion years, and that the kinds of radiation and the temperatures do provide for a habitable zone. And what's really interesting is that because of the difference in brightness between the white dwarf and the planets beside it, then it actually is the kind of thing that James Webb could study with just a few hours of observation time. So it could be that if we don't find any atmospheres around red dwarf planets, maybe now astronomers will look for atmospheres around white dwarf planets. Every week we do a vote on our channel where you tell us what you thought was the most interesting news of the week. And this week the winner was testing robots that could go under the ice on Europa. And so thank you everybody who voted. We'll post the poll again this week within 24 hours to the community tab. So while you're scrolling on YouTube and you see the new poll come up, take a second and vote and tell us what you think. And of course, the best way to see the poll is to be subscribed to our channel, click on the notifications bell, and then interact with a bunch of our videos to train the algorithm. And the algorithm will train you. All hail the algorithm. Interstellar objects can't hide from Vera Rubin. Astronomers know of two interstellar objects now, Oumuamua and Borisov. And both of these formed outside the solar system, traveled through interstellar space, and arrived in the solar system and then passed through, and they're heading back out to explore the Milky Way. And because we know of two of these objects, that allows astronomers to calculate how many are probably passing through the solar system at any time. And it could be thousands, if not tens of thousands of these objects passing through the solar system. But they are very hard to see. Space is big, but good news, the Vera Rubin Observatory is coming online in just a few months, and it is the perfect machine to find interstellar objects. So astronomers created a bunch of simulated interstellar objects in simulated Vera Rubin data, and then they trained a bunch of machine learning algorithms to see if they could find them, highlight the interstellar objects. And it turned out they were able to find several algorithms that were very effective at finding them. And based on those calculations, they think that they're going to find hundreds of interstellar objects in Vera Rubin data within the first year. Hundreds of interstellar objects. It's crazy. Man, I'm excited about Vera Rubin. How to rescue astronauts from the moon. Hopefully we're going to have a larger and larger presence on the moon with astronauts in a base, and they're going to be exploring the area around them. But that also means there is the potential for a disaster where one astronaut becomes incapacitated, and it's up to the other astronauts to be able to get them back to the base station, to the spacecraft, to rescue them. But trying to rescue an astronaut on the moon is going to be tricky work. You've got the temperature extremes that happen on the lunar surface. You've got the lunar regolith, which is trouble. And then the suit themselves. The new lunar mobility suits being developed by Axiom Space weigh 343 kilograms or 755 pounds. Now, of course, you're in 1/6 Earth gravity on the moon, and so they feel only 57 kilograms or 125 pounds. But still, imagine if you had to lug back home somebody that weighed 57 kilograms, I guess plus their body weight. It's not going to be easy. So NASA has a new challenge called the South Pole Safety Designing the NASA Lunar Rescue System. And they are going to be paying out a total amount of $45,000 in prizes to teams that can design a way to rescue astronauts from the lunar surface. They need to be able to carry an astronaut 2 kilometers up a 20-degree slope on the moon, dealing with the temperature and the regolith without dragging them behind a rover. So if that sounds interesting to you, they're accepting entries to this challenge until January 23rd, 2025. Webb sees a supercluster coming together. So let's consider our little corner of the universe. We live in the local group, and that consists of the Milky Way, Andromeda, and the Triangulum Galaxy, as well as a few dozen dwarf galaxies. That is our cluster of galaxies. Now, when we look out into space, we see larger and larger clusters of galaxies. We see the Virgo supercluster. And one of the largest superclusters ever seen is known as the Spiderweb supercluster. This is a cluster of galaxies that contains over 100 separate objects that are coming together, but the light has taken 10 billion years to reach us. And so we are not seeing a supercluster as it looks today in the more modern universe. We are seeing a supercluster as it was coming together with infant galaxies. And this is the ideal object for the James Webb Space Telescope. Now, researchers published a new image of the Spiderweb protocluster. And what's great about Webb is that because it has this infrared view, it's able to peer through the gas and dust that obscures our view to some of the objects that are part of this protocluster. So they're able to find many more objects. And so when you look at this picture, it just looks like stars. But then if you look very carefully, there aren't many stars, it's actually galaxies. And these galaxies, the light has been traveling for 10 billion years to reach us. And of course, this is a great opportunity to watch as these first giant structures in the universe were coming together. I know like a lot of us can't wait to see whatever is the James Webb version of the Hubble Deep Field. And this is a good example of the kinds of observations that they'll be able to make. But this is done in a fraction of the time than it took Hubble to do its deep field. It's time to look at Jupiter. Once a year, Jupiter enters a region which astronomers call opposition. This is where you line up the sun, the Earth, and Jupiter. They all form a line, and Jupiter is on the opposite side of the sky from the sun. That puts it at roughly its closest point to Earth. It's perfectly illuminated by the sun, and it's the best time to be able to see Jupiter because it rises in the early evening and sets just before the sun comes back up. And so Jupiter hits opposition this year on December 7th. So how can you see Jupiter? Now, you could just go out and see it with your own eyes. Go out after sunset, look to the east, and you should see what looks like a bright star. That's Jupiter. And then you should watch it over the night. It's going to move all the way across the sky, and it will set around sunrise. But then get your hands on a pair of binoculars and you should be able to see not just the planet, but the moons around it. And then if you can get your hands on a small telescope, you should be able to see the planet, the moons, and bands across the planet, those atmospheric bands. And if you're lucky, you might even be able to see the Great Red Spot. So if you've ever wanted to see Jupiter, this is the perfect time to do it. I'm going to talk about the perfect gift for the space fans in your life. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Barry Lake Roofing, David Gilton, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, Spiderswap.io, Stephen Krasaki, Stephen Farlamelny, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So if you're still looking for the perfect gift to give for this holidays, why don't you consider gifting membership to the Universe Today Patreon? Now, the lucky person that you give this gift to will get full behind the scenes look at all of the content that we produce on Universe Today. Get access to the patron-only question show, as well as be able to ask me questions every month and get an answer, guaranteed. Do an interview with me personally. You get no ads on any of our content. You can even play with the screen off. You can ask the questions to the people that I'm going to be interviewing, and then you can hear their answers in longer bonus parts that we release only to the patrons. And all patrons get no ads on the Universe Today website for life, even if you cancel your membership. And we're going to have more perks coming soon. So if you want to give a gift membership, go to patreon.com/universetoday/gift. All right, we'll see you next week.